Okay, this afternoon's technical session, T-36 implementing hard drives. Throughout this technical session, we're going to be able to explain the purpose and methods of hard drive partitioning, explain the purpose and methods of hard drive formatting, and identify common hard drive problems, and explain how to maintain and troubleshoot these issues. Throughout this technical session, the behavior, skills, and mindsets we want to keep in mind are teamwork, because IT very much is a team sport. Skill sets do vary, and you want to kind of lean on those team members that have skill sets in different areas than you. Some of you may be better at telecom, some of you may be better at networking, hardware, TCP/IP, security, and use these opportunities when you come across instances that are outside of your expertise to learn about them and develop more so you can become a more valuable team member. Also, persistence. We have to kind of be like detectives in our efforts to troubleshoot and solve problems. Sometimes it may be beyond our skill set. So in those instances, we may have to hand those problems off to tier 2, tier 3, or specialists within our field. And I implore you, even if you're unable to solve that problem, follow up later, find out what it was they did to actually solve that problem, and kind of incorporate that into your toolbox. The more tools you have in your toolbox, the more valuable you are to your team, and the more valuable you will be to the company as a whole. All right. Partitioning. What exactly is partitioning? Although, much like the name says, it is the process of electronically subdividing the physical hard drive into smaller units called partitions. A hard drive must have at least one partition, thankfully, and they allow to use multiple operating systems on the same hard drive if that is something you wish to do. But Windows themselves supports 3 partitioning methods. The first being the MBR, or Master Boot Record. And then you have the GUID partitioning table, or GPT, which I believe is what is replacing the MBR. And then you have the Windows proprietary dynamic partitioning scheme, or dynamic disk, which is where you would break things up into individual operating systems should you choose. And if you're wondering, GUID stands for Globally Unique Identifier. So this is one of those unfortunate situations where you have an acronym within an acronym. Unfortunately, I would love to say that it gets better, but it doesn't. It does get worse. There are times where it's like 3 layers of acronyms to a single one. So we try to remember them as best we can. So globally unique identifier. This can be used for software, for hardware, for files, things like that. Just, it's an algorithm that creates a unique number for each specific item that you wish to set up the GUID on. But for the most part, that is beyond the scope of the A+, just kind of giving you a basic understanding as to what the acronym is for. All right. MBR. See here, Stephen, can you read for us, please?
Yeah. Hard drive using MBR partitioning scheme have a tiny bit of data in its first sector that is also called master boot record. MBR also contains the partitioning table, which describes the number and size of partitions on the disk. MBR partition tables support up to 4 partitions. When
there you go.
PC boots up.
Keep going. Yeah, keep going.
PC boots up BIOS, look at the first sector of the hard drive for instruction in the partition table to determine which partition contains the active operating system.
There you go. So the NBR is always in the same location. It's in sector 0. Because this basically lets the computer know or whatever where everything else is located on the hard drive, how the hard drive is broken down, and essentially a map to find those things. So an NBR supports up to 4 partitions. Next, Vincent, can you read for us, please?
MBR partition tables support 2 types of partitions, primary and extended. Primary partitions support bootable OS, while extended partitions are not bootable. A single MBR disk may have up to 4 primary partitions, or up to 3 primary partitions and 1 extended partition. Primary partitions are usually assigned drive letter, started in C. Each primary partition on a single drive has a special setting stored in the partition table called active that determine the active partition. Grub boot manager is used to control multi-boot setups with 1 unit's OS.
Thank you, sir.
Wow.
So Grub Boot Manager will operate within Linux. Don't worry. You'll get a chance to play around with this. Not in test out. I think test out does have a lab for it, but the one that will be near and dear to your heart will be the one that we do in Coursera for this. And then you'll sit there and contemplate, why would I ever want to touch Linux ever again? To that, I usually respond, it gets easier the more you use it. So primary partitions are the bootable drives that you would put your operating systems on if you were setting up a multi-boot, or you could run extendeds, which would be just dividing up yours hard drives into multiple storage spaces. All right. So extended partitions can contain multiple logical drives, each of which can get a drive letter. Logical drive works kind of like a primary partition, but you can't boot an operating system from it. Say you wanted to create a drive where you would want to keep things for work and you would want to share that drive. You don't want to share everything that's on your computer because that's your personal stuff. You know, you don't want your coworkers going in and looking at your family photos or videos or something like that, or looking through your movie library. You want them isolated to the things that are required for work. So what you would do is you could create a partition, an extended partition like this, name it drive E, and then share drive E with your coworkers. So all the work related stuff goes in that one drive. Nothing else needs to be, you know, shared with them. And it makes things just a lot cleaner and easier in that sense. All right. Dynamic disks, or dynamic storage partitioning, create structures called volumes. The number of the volumes that can be created in hard drives is not restricted. You could have 1,000 volumes on your hard drive if you so choose. Why you would want to do this, I don't know. Some people like to. Maybe you have a monstrous size hard drive and you want to just break it down into functional units. Dynamic disk allows to implement RAID, span, stripe, or mirror over multiple drives. Okay, so we know what RAID is. What's striping? I know it's part, you know, some RAID can do that, but what is striping? Someone had to have done the reading.
Striping is mirroring of a drive. So it's basically the first drive is, the second drive is a copy of the first drive. So it's type 0.
Not quite. Not quite.
It's when you store data over multiple drives. Like, let's say you have data that's 10 parts, right? Part 1 goes into the first. Well, this will be over volume. Sorry, not drives. So this will be over the first volume. Then the second part will go into the second volume, and so on and so on.
Okay. So you take So like if I have a file that composes of 10 bits, bit 1 would go into volume 1, bit 2 would go into volume 2, bit 3 would go into volume 3, bit 4 would go back into volume 1, bit 5 would go into volume 5, or volume 2, excuse me, bit 6 would go into volume 3. So it would keep rotating through the volumes, striping across all the volumes, right?
Yeah.
Or drives, because you can have multiple drives in there too.
Yeah,
So
yeah.
you can stripe across multiple drives. So that's striping. What's mirroring?
That's a copy of the volumes.
There you go. That's a copy. So whatever I put in volume 1, if I mirror it to volume 2, and that could be a section of disk, or it could be completely different drives. So if I put bit 1 in volume 1, bit 2 is going to go into volume 2. So it does a complete exact replica into each drive. That's mirroring. Let's take a, huh?
I said I'm getting better at those. Thank you, Kelly.
Hey, we get there over time. Again, don't be afraid to get it wrong here. I'd rather have you speak up and possibly get it wrong here. That's fine. Get it wrong here 10, 20 times, so long as we get it right on the exam. Who wants to take a chance on spanning? What is spanning? So we know what striping is. We know what mirroring is. What's spanning?
Not like expanding the memory.
Go on.
To make more memory in the drive.
I can restate the same thing in a different way. Yes, so to a degree. So say I have a file that is, 3 gigs, but I have two 2-gigabyte hard drives. I would fill up one drive completely, but then it would allow me to spill over into one of the other drives to fill up. So striping, I would put 1 bit in one and then 1 bit in the other and kind of alternate back and forth. Spanning kind of allows you to fill one up and then spill over into another, but it would still treat them as the same drive. So if I put the 2 drives together and span across them, it still treats it as if it's a single drive. But it's still 2 drives, but it allows me to spill over into the other one is full. And then when I go to retrieve that data, it's still logically treating them if they're a single volume. So I can create a single volume out of 2 drives as opposed to creating multiple volumes in a single drive. Yes, DW.
No, yeah, that's what I gathered. You can also define a drive to be like part of a span into another one. So let's say you have drive 1 that's all memory, and you have a backup one. You can make that second one half of it or a third of it, make that span with the first one, and that way you increase the size of the first drive and still can use the other section for whatever else you want as well.
Excellent.
I thank TestOut for that.
You thank TestOut for that? That's
Yeah,
a good one to thank. TestOut is such a great tool. Often neglected, unfortunately. We try to give it some more love while we're here. So we now know the difference between spanning, striping, and mirroring. Now, of all the ones that you need to know with regards to Windows 7, 8, 8.1, and 10, only the lower versions of 7, the lower end versions like Home, or was it RS, don't allow dynamic disk support. All right, now we get into the GUID partition table, which is that globally unique identifier partition table. It is similar to the MBR, but with some notable improvements. It now allows an unlimited number of partitions, theoretically, although Windows limits you to about 128. Unlike MBR, where you would have a maximum partition size of about 2.2 terabytes, we can now exceed that with the GPT. Now, GPT is arranged by LBA instead of sectors. And 0 is the protective, like the MBR. That's where it always goes. The master boot record always goes in sector 0. All right. So GPT uses a GPT header and partition array. Both are located at the beginning and end of the drive. So there is kind of a protected backup. It's a redundancy in case one of the sectors gets damaged or overwritten, then it would have another place to locate those particular files. All right. Now, Windows can boot from the GPT on UEFI, which, as we remember, is the replacement for BIOS in the system, and off of 64-bit versions of Windows, which is your 10, 8.1, 8, and 7. Also Vista, and now Windows 11. Although that one's quite buggy at the moment. So all these versions can read the GPT drives and use them for data. All right. Linux has built-in support for GPT, even with older BIOS or UEFI firmware. Apple used to use something called the Apple Partition table, but they started moving over to the GPT as it was a more efficient system. All right, so when would you want to partition a drive? First off, when you're installing your operating system onto a new system, you would want to do the partitions at that point. Or when you're adding a new drive to an existing system, you would need to add that volume and then how it would be set up. So there's two tools within Windows for partitioning hard drives. You have the command line interface, or CLI program, called fdisk, which is obviously the oldest one, being in command line. And then you have disk management, which is a GUI-based interface, pretty user-friendly, relatively intuitive for creating volumes. And I will say, know the steps for partitioning a hard drive in Windows, because you will be asked about it on the A+. That is pretty much a certainty. No, partitioning is not similar to defragmenting a hard drive. Defragmenting is taking little pieces of information that has been scattered across your drive and putting all those pieces that are supposed to together. Whereas partitioning is taking the whole of a drive and cutting it up into smaller useful units. You have a question, DW, or you're just kind of hanging out like this?
I was hanging out, but I'll take advantage of your phone.
Oh, okay. There you go.
So when you partition a drive, are you making it? Is it safe to say that you're making new smaller logical drives?
Yes.
Yeah. Okay.
So it's like a pie, you have like 100% of it, but you're taking like 25% off to do something over here. You take another 25% off to do something over here. And you can set the size of that volume, to whatever you need it to be, as long as you don't exceed the storage space of your drives.
And so the system recognizes each partition as its own individual drive at that point.
Yes.
Okay.
And they would have unique drive numbers. So you, instead of just everything being drive C, you could partition off, say, 30% of your hard drive and make it partition M if you wanted to.
Right.
or
novel
W
in my
for
hand.
work or something like that. So. All right, formatting. So formatting, it does two basic essential things. One is it essentially creates a framework for the file system, and then makes a root directory in that file system. And the root directory itself provides a foundation upon which the operating system builds your files and your folders. It has to have, like each partition you create, you have to format it or create the format in order for it to be able to hold data of any kind, because you need to essentially lay down that map for how the computer is going to be looking to collate that data or put that data together in some useful manner. So you have your built-in formatting utility, which also is your disk management. And then you can create different file systems, and the versions we have here for Microsoft are FAT16, FAT32, Ntfs, and FAT64, which is also known as exFAT. And these are the basic file systems that you can choose from depending on your needs within Windows. So FAT16, it is the lowest base storage area essentially that you can set up. Each sector stores up to about 512 bytes of data. If the file you're trying to write is smaller than that, that rest of that sector goes completely to waste. So if you have a file that is like 520 bytes, it would write 512 into one. The next sector would use 8 bytes, and then the rest of that sector would literally go to waste. So, and once it writes the file, obviously it has to remember where this file is so that it can look it up later. Which gets us to what FAT stands for, which is File Allocation Table. Now, it is basically a kind of like a spreadsheet, but a map as to how the files are laid out. It's in a hexadecimal format, and it can be anywhere from 4 zeros or 0000 or 4 Fs. And there are 64,000 sectors that can be tracked. Now, the right column of your FAT table contains the information on the status of the sectors. When nothing is written to the sectors at all, and they're good, those sectors are marked with 0000, means that they're good to write to. Tells the computer everything's fine. You can write to this when you need to. If the sector is bad through the formatting process, we've determined that there are bad parts of the drive. If it's bad and it should not be written to, it will put a code on it, FFF7, and that lets the computer know, do not write here under any circumstances. Do not create a file upon these sections. So all zeros if it's ready to receive information, FFF7 if it's a bad sector and cannot write there at all. All right. So, clustering. So FAT 16-bit FAT's limited to 64,000 times 512 bytes per sector, or 32 megabytes. So you need to remember all of this information? No. With regards to A+, beyond A+, yeah, possibly, but we do have our coworker Google, who can help us with our mental lapses from time to time. So, get into clustering. which allows us to enable partitions larger than 32 megabytes. Because if you think about it, how useful is a 32 megabyte cluster? Not very useful, is it? Heck, I don't even know if you could put like the original like Doom on 32 megabytes. Not sure. Maybe you could. So clustering itself refers to combining a set of contiguous sectors and treating them as a single unit in the file allocation table. These units are called clusters. The size of the cluster is not fixed, thankfully. The larger the partition, the more sectors per cluster. New FAT16 supports partitions up to 2 gigabytes. Maybe not useful in a hard drive on a computer. Where might this be useful? Based on the size alone.
On a phone?
Even on a phone, that's a little too small for even operating systems on the phone are larger than 2 gigs. Yeah, tape drives. Candida's got it. Flash drives. It's not uncommon to see a flash drive less than 2 gigs, right? So that would be a useful place to use FAT16. All right. Here is a look at a file allocation table. Now, so first we got our clusters, which is here, which kind of goes all the way up, from 0000 all the way up to FFFFF, right? Now, the status over here tells us, like with the 4 zeros, what does that tell us? That we're able to receive data, right? So on the allocation table, it's telling us 4 zeros. It means it's an empty cluster. It's able to receive data. What does FFF7 mean?
We cannot write data in there.
Cannot write data in there. It's a bad cluster, bad sector. So lets us know that it's a damaged piece of hard drive. So when it starts to write, write to the clusters, excuse me. So it starts to write to the clusters. So let's say we have a file that starts at 3ABB. When it writes, it fills up this cluster. Status gives us the next cluster, 3ABC, to tell us where to go for the next bit of information we need. And then once it fills up that one, it gives us the next one again, 3ABE. Why didn't it give us 3ABD? Because D would come after C, right? Why didn't it give us 3ABD?
Is not writable.
It's a damaged sector, FFF7. So it's damaged. So what it does is it's going to move to the next sector that it's able to write to. So instead of 3ABD, it gives us 3ABE. So it jumps over this one and comes here, fills up 3ABE. We have all of our data written. We don't need to write any more data. So in order to close out the file and let the system know that is the end of the file, we put FFFF. Lets us know that is the end of the file. There is no more data needed. And this is how, when you write to a hard drive, the hard drive records where all the information is going. And here we thought it all happened automatically, right? So we can go down to our next file here, 3ABF, and then it goes to 3AC0. 3AC0 goes to 3AC1, 3AC1, FFFF, end of the file. So in looking at this, when you're deleting and writing files frequently, you can now see how these files kind of get scattered all over the place, right? Because the files you're writing into the sections after you deleted something aren't necessarily the same size. So to be able to put like the first quarter of it here, and then it's going to have to skip over until it finds an open sector and then put the next chunk in, right? And when the drive, the head on that hard drive is going around looking for that information, it's now having to skip all over the place to find all the pieces of the file or the movie or the music or whatever it is you're looking for, which can slow things down, which is why we actually defragment, because then it rewrites all these file pieces to be right next to each other rather than scattered all over based off of this file allocation table. Does this make sense? Big takeaways. The cluster name, your statuses, meaning the 4 zeros and FFF7. 4 zeros mean you can write, FFF7. Bad sector. And then it's just basically a map. It tells you where to go looking next. And then when you reach the end of a file, 4 Fs. And it means you need to look no further. All right. Next, FAT32. FAT32 uses 32 bits to describe each cluster. It supports partitions up to 2 terabytes, which is getting really useful now, and allows for a much more efficient use of your disk space without the need to make multiple small partitions in order to work with large file or large drives. However, it needs that defragmentation about as often as a FAT16 does. FAT32 is still pretty commonly used today. It's used for predominantly USB drives. So FAT32 still heavily used. Again, mostly in your flash drives. Typically used in smaller than 32 gig hard drives. Now, the big dog of the group, the one that is most commonly used today, is our Ntfs, or New Technology File System. It still uses file allocation tables, but it is significantly more complex with regards to this, and also offers up some security functions. So Ntfs uses the MFT, which is the master filled table. And Ntfs partitions keep a copy of the MFT in the middle of the disk to reduce the risk or chance of losing the MFT and its copy. So for security functions, it views individual files and folders as objects. Key, remember that. It views individual files and folders and objects and can provide security to those objects through the access control list. Where would we normally see an access control list? When we hear that term ACL, or access control list, what should we immediately think of? Not the switch. You're getting warm. getting hotter, we would say. Almost on fire. Nobody picking up on the clue? Yes, Rachel. Nope, your mic didn't turn on.
Firewall.
Yes, firewall, firewall. So when we hear ACL or access control list, our minds should immediately start thinking firewall. So the Ntfs allows us to view each individual file or folder as an object that can be restricted by the access control list or the firewall. All right, Ntfs enables us to be able to compress individual files and folders to save space on a hard drive. Although the downfall of compression is time. We save space at the cost of time. It's slower in order to read and write that data down from the, to the drive and from the drive, because you have to compress and decompress that data, much like encryption. Encryption is such a wonderful thing. Like we were saying, like we have on here, where you have the EFS or encryption file system. If you remember, BitLocker locked the whole drive, and then you had EFS, which was the file level version. Ntfs is what it enables that. Encryption is wonderful. It's awesome. It helps protect our data at the cost of time. It's going to slow things down because of the computational power that is required to encrypt and decrypt that data so that we can use it. Disk quotas is another one, which is a great one for administrators because there's always a data hog in the office. It allows administrators to set storage usage by individual user. Like, Rachel would only be allocated 1 gig on the share drive. So when she gets to her maximum on that, it will no longer allow her to save more files to the drive. She can request more space, but it allows us to set quotas so that we don't have somebody just jamming a whole bunch of stuff onto the share drives. Cluster sizes. Ntfs allows us to actually adjust the size of the cluster, and it supports partitions up to 16 terabytes, which is pretty big. On dynamic disk, but on basic disks, unfortunately, only up to about 2. All right, finally, start talking about FAT64. So FAT32 supports drives up to 2 terabytes and files up to 4 gigs. XFAT or FAT64 supports files up to 16 exobytes. Who wants to Google that and tell us how big that is? How big is an exobyte? Somebody else can look up zettabytes because it allows a partition limit up to 64 zettabytes. No Googlers out there? $1 billion with a B gigabytes. Yes, Karen.
A zettabyte is 1 sextillion bytes.
1 sextillion?
Am I reading that right? The number of bytes is equal to 2 to the 70th power.
2 to the 7. That's insane. 2 to the
Also-
70th power.
Also
Zettabyte.
expressed as 1 sextillion bytes.
1 sextillion bytes. So now what is
Them
that?
sound like some
Because you
DNA
have
numbers.
quadrillion, and then quintillion, and then sextillion.
Yeah, them sound like some DNA type numbers.
So roughly 1 trillion gigabytes. I don't care how many movies you have, you're probably not going to need that at your house. If you have storage about that big at your house, likely some guys in suits may want to come talk to you after a while. All right. USB drives don't use Ntfs because its security encryption make access difficult when moving the drive between systems. So Ntfs, unlike FAT32, FAT16, can't be used. FAT64 on some of the larger, we're starting to get to the point where we have much larger USB drives. Like I've seen USBs at about 1 terabyte now, like flash drives at about 1 terabyte, which is quite incredible. So FAT64 would allow us to actually format these larger drives and make them more usable, because Ntfs would not be a viable option. I can neither confirm nor deny, Karen. All right. File systems in Linux. Most Linux distros or distributions use X4 by default, and the older ones used X2 or X3. But X4 is going to be your most common currently. They can read the Ntfs, the FAT32, the FAT64, and the HTF from Mac. Now, here's the thing for you Mac users out there. You need to be careful what file systems you're using when you're saving documents, especially to USB drives and to external hard drives. If you're going to be sharing this with other systems, like if you're going to be sharing it with Windows users, because if you're saving it in a Apple's proprietary, like the HTF, it will not be readable by the Mac users. So you need to be careful what file structures you set up, depending on how you're going to use the data. Now, X4 strengths art supports volumes up to 1 exobyte and individual file sizes up to 16 terabytes. And then it can contain roughly about 64,000 subdirectories. This is a question that gets a lot of people on the exam. What type of file system do they use for CD-ROM? It seems so on the nose that most people think, nah, that can't be it. But it is CDFS, or CD file system. So if you ever get asked, what is the file system used on optical drives or CD-ROMs? It's CDFS. Blu-ray and DVD use UDF, or Universal Disc Format. So CD-ROMs, CDFS, Blu-ray and DVD, UDF. UDF. Other one to be aware of is the network file system, or NFS. It was developed by Sun Microsystem. Kind of makes files accessible over the network and are stored on local computers. Even if the host computer uses a different operating system like Linux or Mac OS, it would still allow them to use it if you're operating from a Windows machine. Questions? All right. Quick format versus full format. Anybody who's formatted their hard drive has been addressed to this question and was like, what the heck is the difference other than time? The only real difference between quick format and full format is quick format does not look for errors in the drives. So before it creates that file allocation table, it basically just does a quick reset of the file and it goes from there. Full format actually checks the viability of all the sectors, notates which ones are bad so that you do not write to bad sectors. So whenever time allows, full format is your best option. And for those of you who are wondering, formatting does not erase the data. The data is still there. So if you have sensitive information, formatting does not get rid of it. It basically just tells the computer it's okay to write to these sectors. The data is still there. Anybody with a semblance of IT knowledge can reconstruct the data from an unformatted drive, or a formatted drive, excuse me. So it is not a security measure to format the hard drive. All that does is basically just tell it it's okay to write to these sectors or write over this information later. So, but until that information is written over, it's still able to be read and reconstructed. Yes, DW.
I think I was going over something in Intestado that a specific kind of formatter like writes over it like a certain amount of times to make that data unreadable. It's like 7 times or something like that. Or was that you that told us something like that? I don't know. That's just like
it was probably both. I probably briefly mentioned that, but when we start getting into data destruction and disposal, we'll talk about that a little bit more in depth. But yeah, that's different than formatting though. That is essentially, it's a wiping program where it basically writes random 1s and 0s over each sector multiple times. 7 or 8 is about a minimum standard, although you do have some that go way higher than that. So I think that's one of our last technical sessions is data destruction and disposal. All right, here's a quick look or, snapshot of your disk management tool in Windows, where you can set new volumes to create new partitions. You set the type of file system you're going to use, how big of a volume you're going to create. Are you spanning that volume across multiple drives? All that kind of fun stuff done all from here. You can name the drives whatever you want to name them. I believe it's A through Z. Although typically you would start at D and then go up from there, historically speaking, but you can pretty much allocate whatever name you wish to it or whatever letter you wish to it. Troubleshooting partitions. Basically, your errors fall into 2 categories. You have a failure to partition. Eventually, I'll wake up enough where I can speak. and making the wrong size partition. So when you want to fix that problem, you open up disk management and do the partition correctly. If the problem is in the secondary drive, and if the problem is in the operating system partition, use the CLI in Windows tool. So if the disk management is failing to make that partition, regardless of what you do, go into the command line and create it through the command line. Again, Test Out has a lab where it walks you through both methods. I would suggest doing that a couple times, become comfortable with it, because part of the beauty of Test Out is creating that muscle memory. Because having the certification is great for getting your foot in the door. Being able to perform these tasks will aid you in keeping that job. So, failing to format, drive makes the drive unable to hold data. Accessing the drive in Windows results in drive not accessible error or invalid media type error. Corrupted files can create the invalid media error as well. So when you run across this, going into the CLI and reformatting it from there. Physical problems. Hard drives manifest themselves in several ways. They have read and write failures, lots of noise, or drive itself seems to disappear. Had that happen yesterday when my 4-year-old snatched the cables out of my hard drive. Got a big fat error. And then a moment of shock when I was witnessing my drive being thrown on the floor. And then I had to walk away. Symptoms. Mechanical drive begins to make any of the following sounds. It is about to die. High-pitched squeal. We talked about that one this morning. You'll hear that essentially one time in your life, and you'll never forget that sound. Loud clicking noise, short pause, then another series of clicks. Or a continuous grinding or rumbling. Metal on metal sound, I don't care what device you're using, that's never good. Whether it be your car, computer, what have you. Metal on metal grinding never is a result of something good. All right, solution, drive is about to die. Back up your data immediately and pray you get through the backup process before failure ensues. When a hard drive with the operating system dies, the system itself will lock up and it will give you no boot device present. If it is a secondary drive, it will stop running. It will show up in a Windows Explorer. In that case, both the power and data cables and connectors should be checked just to verify. Quiz time.
Daddy,